Welcome. Quick question. How many of you were in the talk that just happened in the same room a couple of minutes ago? Oh, actually not so many. That's good, because my previous speaker said he thinks that we are not talking enough about issues in the software supply chain, and it's rarely ever discussed at conferences. SteelCon decided to push that topic and accepted both our talks, and there's quite some overlap, but also for those of you that were in the last talk, I hope that there are still some new aspects in my presentation as well. Even so, a couple of examples you will recognize are actually the same, and a couple of things will be not new to you. Quick about my background. I recently joined the University of Exeter as a professor in cybersecurity. Before that, I was a couple of years here in Sheffield at the university, and before that I was working in the central security team of SAP, and among that being involved in solving or trying to solve the issues of SAP's software supply chain, SAP's consumption of open source, so tackling those type of problems for a development organization with something like 27,000 developers worldwide, and you can guess if you have 27,000 developers worldwide, there's a lot of external libraries that are consumed and that are a potential threat to the security of the software that is offered by the company. So just this week we've seen these headlines in the news: BA potentially fined due to a GDPR violation based on a data breach they had last year. We had 2 years ago, I think it was, Equifax, also a massive data breach. And what do those two breaches have in common? If we look at the actual root cause of the breach, then we are talking about software vulnerabilities, bugs that allowed an attacker to do something malicious in libraries used by the company. So in the case of BA, it was a JavaScript library they included in their website. In case of Equifax, it was Apache Struts, Java library they used that had a known vulnerability in there. It wasn't fixed in time by Equifax and enabled the attacker actually to obtain data they shouldn't be able to obtain. So what they have all in common is that attackers exploited a known vulnerability. We are not talking about a 0-day. We are talking about vulnerabilities that have been published already as CVEs. Fixes were, at least for the Apache Struts one, already available at the time of the attack. Potentially also exploits were available publicly, freely available. So exploiting those vulnerabilities, not very difficult. They're in an external library. Neither of the software bugs that have been exploited were developed by developers of BA or Equifax, but still, both companies are liable for the data breaches that were enabled by those vulnerabilities. So the first lesson that we are learning here: if you ship a piece of software, if you offer a software as a cloud solution that includes external libraries, you are liable for everything that you are shipping, including the stuff that you haven't developed yourself. And things are changing. Let's have a look how we develop software today. So, when I started programming, I'm an old guy, that's visualized on the left-hand side. I still needed to go to a library, these big halls with books, and started to look for a book that told me how to program Hello World. Most likely it was a C book, Carnegie Ritchie, and I had to write something like 10 lines of C code. I could compile it, and it printed Hello World. I did the same exercise rather recently. I googled for Hello World program. How do I do that? And incidentally, the first link that I got was a solution using NPM, Node.js, Express libraries. Actually, the amount of code that I need to type into the system is roughly the same. Not all program code, I have to type a little bit more configuration. It works also pretty nicely, but if I look at what the system is doing when I'm compiling or configuring the program, it's downloading over 20 external libraries where I have no idea who implemented them, nor what quality they have, and honestly, not even what the purpose of those libraries is. So, while 20 years ago, we were developing software where most of the software that we were shipping to customers or offering it to customers was our own. I visualized that with the red Lego blocks here in that wall, which visualizes this piece of software that we are developing. Today, it more looks like this, much more colorful. Only a small fraction of the code that we are shipping is actually developed by ourselves. The rest are libraries developed by anybody on the internet, more or less. And that's the second learning that we need to keep in mind. Today, most likely the software, the code that you are writing as a software developer is only a fraction of the software that you are offering to customers. I found a nice comic script that visualized that as well, and I needed to put it into the presentation because it is so nice. So we have here those two guys. This is the code base. It's amazing how such small things can do so much. And then, look what is underneath. A lot of dependencies, and it visualizes nicely, at least from my perspective, that as developers, we often do not know what all those dependencies actually do. And we don't know if the dependencies of dependencies of dependencies, why they are actually included in our project. They are just lying there and doing something. While, short clarification that I want to add here, while I will talk today mostly about free or open source software, everything what I'm discussing applies to all types of external libraries that you can work with, starting from proprietary libraries or outsourcing, where you ask a company to develop a library that you then are using, or a component that you then are reusing for your actual implementation, over freeware, so gratis software that you are not paying for, but you don't get the source code, over to open source libraries. The main reason we are discussing the topic of software supply chain issues, mostly in the open source world, is twofold. Firstly, they are very, very easy to access for developers. If I have proprietary libraries, I need to pay somebody. And that means if a software developer wants to use such a library, he or she needs to go via the procurement department of your company. And that will trigger a couple of bells and there will be a contract negotiation. Whereas for the free stuff that is offered on the internet, a developer can just download it and include it. So it's the easy availability that makes this the area where people are discussing the supply chain issues more. And freeware, honestly, nowadays is not that important anymore. Most of the freeware that I have seen in my professional development life were actually drivers for hardware. So you had already a support contract with the company because that company, for example, was selling Bluetooth headsets, and you got some freeware driver from them to talk to that Bluetooth headset. So they are more kind in that proprietary library side than in the open source side. There's also licensing issues, and open source software has different licenses, and of course we need to comply to them. I will not discuss that part at all in the next 40 minutes or so. Who recalls Heartbleed? Big vulnerability in OpenSSL. OpenSSL is a library that implements TLS. That's, so to speak, the S in HTTPS, so the core library that provides the transport encryption for all the websites, or most of the websites that we are accessing. In 2014, that library had a vulnerability. And while at the beginning we thought that it's actually pretty hard to exploit that vulnerability, later on we learned that it's not that hard, and it allowed an attacker to obtain the private key of a server. So it was actually a rather severe vulnerability. And moreover, for every customer, it was easily detectable which version of OpenSSL you were using, because that was a library that offered, so to speak, a port that your application offered to the outside world. You only needed to look at the details of that port configuration, query the hello message, and you could kind of see what version you were using. And the customer started to call in, you are using a version of OpenSSL that is potentially vulnerable. Are we affected by that or not? And if yes, what should we do? And if you are now in the position of being a security expert or a product security officer in a software development team, you suddenly need to know which of the products I'm responsible for is using that library, because they are potentially vulnerable. Secondly, which of those products are actually vulnerable, because the vulnerability might lie in an area of the library that you are not using. It might be in a feature that you are not using. And then you also want to know if customers are actually already using that product. So there's a lot of questions that you need to answer very quickly to satisfy your customers. And in parallel, you need to start the process of deciding if the products that you are developing can be upgraded to a later version of that library that includes already a fix, or if that is not available, if there are other methods for protecting your application against that vulnerability, implement that, go through your usual testing process, and 3 to 6 months later, ship a new version to your customers. Hopefully not 3 to 6 months later, but that's roughly how commercial software development works. So the initial idea that people have is, the open source guys, they're always updating their libraries and they're fixing vulnerabilities if they are known. So let's solve that issue by we are always using the latest version and we update dependencies as quickly as we can. That seems like a good idea, at least on the first look at it. And it works for certain development cultures and certain products. If you are, for example, a company like this one, and if you look closer to on those pictures, you will see here Steve Wozniak. Those are all people waiting in line for Apple stores for a new Apple product. Apple, at least for quite a while, had that advantage that people were very keen to upgrade. They had a rather recent iPhone, a new one came out, they wanted the latest version. If you're in that market, it's no problem. You upgrade all your dependencies in your latest product. Your customers will switch immediately to the latest version, and you don't need to support the old ones anymore. That's kind of what I sketched over here with the green bars. On the y-axis, I'm sketching the numbers of customers a product has, and on the x-axis, when was the product originally released. And we see here the green part, most customers are kind of using the latest or the version prior to the latest release. If you're in that kind of business, web browsers nowadays are in that kind of scenario. They're doing auto updates themselves. Adobe Acrobat Reader switched to that model a couple of years ago. Then the idea of upgrading your dependencies as quickly as possible works nicely. If you're more in a conservative business environment, let's say you're producing enterprise resource planning systems like SAP does, or you're developing systems that are hard to upgrade, IoT, and that have a long lifespan, your smart car that you want to use in 15, 20 years still, then you are suddenly in a business where most of your customers are using systems that you released 10 years ago. And then, of course, all the dependencies they are using in the systems they have in the field are also 10 years old. And there are open source projects, like, for example, a number of the Apache projects that have maintenance life cycles of 8 years. A lot do not have. And then suddenly it's your obligation to update that library, to fix bugs in them, to decide if you can downgrade something. So always being very fast doesn't work. And there's actually another risk in upgrading your dependencies as quickly as you can. That was in news 2 years ago. And that was literally a developer who retracted Node packages that he developed, and they were down to 3 lines of code. And that then opens up the question, does it make sense to use an external library if the complexity of that library is 3 simple lines of code and effectively an addition of 2 integers? That is debatable. Anyway, he pulled them off Node, and suddenly a hell lot of build processes from companies didn't work anymore because they were automatically pulling the packages from the NPM repository. The package was no longer there. And yeah, the build stopped, and partly cloud systems, software as a service offerings were no longer be available to companies. Not a good idea, but hey, that's more of a safety issue. That's not really a security issue. Okay, if it's affect availability, but there's no data breach involved. When I read that, and also what I've seen in my industrial life, I thought that's actually a quick way of getting rich. You publish a small module, let's say an NPM module for checking the validity of credit card numbers. If the number a user entered is actually a credit card number. That's a useful tool. It's not unlikely that if you publish that after a while, some large companies are using those modules in their website, and then you start adding some code to it that sends the credit card numbers, the credit card data, in addition to their servers, also to your server, and you push an update, and you just wait. You make it a minor update, there's a high likelihood that they automatically switch to the latest version, and then you just sit there and collect credit card numbers and do whatever you want to do with them. And of course, the same scheme can be applied to web services, JavaScript libraries that are offered via CDNs. So it's not bound to package managers as such. Wait, that will never work. Who would be stupid enough to do that? Recall, everybody can publish NPM packages. And one reason why there are so many packages for NPM or Python on the pip repository is actually that it is so easy to publish packages, and there is no heavyweight process in validation, code reviews, and the like. It's an open market, everybody can offer something, and it's the responsibility of the consuming party to check that whatever I'm consuming fits the purpose. So that's easy. They are not checked. So it might actually work. And indeed, there are attacks like type squatting. So which one of those 3 packages is actually CoffeeScript? We have CoffeeScript with and without hyphen. We have camel case. Actually, none of them. It's CoffeeScript with 2 E's and without a hyphen. If I publish one of those packages, for sure, with the wrong names, there is also a likelihood that somebody will use them. And that's a type of attack. And then, of course, there are all those type of attacks where I'm attacking the developer of a benign library, compromising accounts, do social engineering, try to commit a patch to a repository that fixes some issue, and pickback something that does something that is to my advantage. So there are ways, and one example is a case where somebody inserted crypto coining mining code, or not mining code, actually code for stealing cryptocurrencies from a wallet into a JavaScript library, and that got published on NPM. And that was actually a targeted attack, and several inconveniences came together. It started with that one library that is widely used. Event stream got a new maintainer. That new maintainer started to refactor the code, improve the library. By doing that, he added a dependency to a JavaScript library called FlatMapStream. Nothing bad there. That change in maintainer was a regular maintainer change, which happens. He published that as a major version, which means that users of the event stream library did not automatically upgrade their systems. A manual upgrade was required for moving to that new version, that was still a minor update, so the people automatically upgraded to the version that suddenly required that additional library. Then actually he reverted that change, but published that as a major version, which meant that people would have to upgrade manually. So a lot of people were still on that version requiring FlatMap Stream, and then somebody was able to add to a new release of FlatMap Stream, and it's unclear if that was intentionally, if that was a bad guy. I've also removed all the GitHub accounts here for that reason. A minor release to that FlatMap Stream library that contained some payload for stealing currencies, money from a crypto wallet. And that was a minor update. So all people using this version of Event Stream automatically pulled that update and potentially were under attack. So we see that in real life. Okay, that is attacking the users of a library and the users of a system that uses a library. Now let's come to something different, not completely, slightly different. There are also attacks that we are seeing, like RIM RIFall. That's a small node module that somebody published just to demonstrate the effect. And if we look closely at the package JSON of that module, we see in line 7 an interesting command being executed as a pre-install command. That's the attempt on a Unix system or Linux system to delete all files. Luckily, the effect is not as bad as it sounds. Attempts of doing that on a Linux system usually reveal that the system is rather quickly in a state where it can't delete any further files before it actually deletes a lot of user data, but don't try that at home. This is an attack against your build system. You're using the library, you consume that library, and wherever you build software that consumes that library, there's a potential risk that it deletes all your files. And this is not the only type of such an attack. There was also, that's a nice real attack, where somebody published a package called crossenv. And there is actually a package which has a very similar name, which is benign, but that benign package is written with a hyphen. And we see that in line 15 over in the script, that malicious code depends on the benign version, and by that easily provides the same functionality. So people using that malicious version get actually the functionality they want. But it adds also a post-install script. And if we look at that post-install script and inspect that closely, we see that it sends data to a remote host that's configured in line 1. I only just simplified that to evil.com. There's some obfuscation going on in sense of that data is being converted to base 64 so that it's firstly isn't destroyed during transport, and secondly it's not that obvious what the system is transmitting. And that data is actually sent to the server controlled by the attacker, and the data being sent that is specified in line 3 is all the environment variables on your build system. This is a very hard to detect attack because you get the functionality that you wanted. You get the functionality of crossenv. Nothing is changed in the actual functionality being expected. The only side effect is whenever you build something with that library, the environment variables of your build server are being exported to the outside. And if you consider what you often do during development, environment variables in the build server often contain information about database servers, account names, and often passwords to some legacy systems. some database systems whatsoever. So that is an interesting information. The question now is, how actually did we detect that issue? And that was detected by a developer. So no security team found that issue. Most likely no security team looked at that. They might have looked at the original cross-env package, and that is fine, but not at that type squatting attack one. So it was actually a developer, a user of that library, who then said, hey, there's actually a similar package, and it does something strange. That doesn't look good. So luckily that person detected that and made the original author aware of that. And in the meantime, Node is installing safety packages on NPM that block those names so that other people cannot upload similar packages. But of course, that only works for type squatting attacks where somebody already tried to attack the system. Node can, of course, not overpopulate the complete namespace for packages with all type of misspellings of benign Node packages. That's impossible. So the rest of my talk, I would like to look at how to minimize that risk. I'm not claiming that I can solve those problems. And I can say already now, there is no silver bullet that works for everybody in every situation. But there are a couple of things that have proven to work nicely and at least help to minimize the risk. And again, you need to pick those that work for your organization, for your style of programming, for your product. So let's look. The first initial idea, of course, is we have an SDLC. We have a security development lifecycle that we use for developing our own software, right? And we have coding styles, and we have security testing tools, static tools. Why not use them to check all the open source that we are including in our product? Sounds like a good idea. Been there, done that, doesn't work. You have no chance of reviewing the code of open source products that quickly as developers request them. And often you have no idea how those open source tools work. And you don't have the expertise to do a security review on them. Even if you're only a mid-sized company, I would expect that you're consuming open source in at least 5 programming languages that none of your developer is using on a daily basis. Being that you're suddenly using Haskell implementations, being Erlang, Scala, whatever. You will use open source libraries where you don't have expertise in the programming language being used or in the build system. So that isn't working. I wasted quite some time in my life doing that. I wouldn't recommend it. What I would recommend, if you are designing a new application, think about how you handle and process data in your application and try to minimize the amount of exposure of critical data to external libraries. If your system is handling credit card data, think which parts of the system actually need to see that credit card data and don't pass it without a good reason via a third-party library that you are not controlling. Minimize the number of libraries or software components that see critical data. That's, in general, a good recommendation for building secure systems. Minimize the amount of source code or components that you need to trust. It's a form of trusted computing with the goal of minimizing the trusted core. And then you can invest all effort or most of your security efforts on that hopefully comparatively small trusted core, because you know that the big part outside of the trusted core is not processing critical data. So it helps you to focus your security efforts. That's clearly a good recommendation. Second, select your dependencies wisely. Why not only select open source dependencies that are secure? One idea that we looked at is, let's look how many CVEs have been published for an open source library. Secure libraries shouldn't have a lot of CVEs, right? Doesn't work either. Our research showed that number of CVEs that are published for an open source library mostly correlates with the numbers of users of that library and the age of the library. Kind of understandable. If you have more users, there's a higher likelihood of security issues being detected. And if something is used for a very long time, people also had more time to find issues, so there's also a higher likelihood. So it's kind of not, at least in hindsight, not so surprising that these are important factors. Actually, one can find an argument the other way around. Libraries that have a lot of CVE values that show that the issues have been fixed have actually a good security culture. They're aware of the problem. And in particular, if we're talking about libraries with an 8 or 10 years maintenance life cycle, the number can be pretty large, and there are still 8 years maintenance life cycle means they have been released in 2011. That were still times where security wasn't that important or that much on our plate than it is today. So there are still legacy bugs in there. So just looking at CVE numbers doesn't work either. But there are factors that help you to decide, is there an active development community? With the argument, if there are active developers, there's a higher likelihood that somebody will find issues and fix them. The other extreme is if the library has no development community, then clearly if you are using that library, you're becoming a maintainer of that library and taking over the responsibility, if not for the public, then at least for your own development teams. No way around that. If you have libraries that offer the same functionality, then it's usually a good idea to use the library that is implemented in a programming language that you feel confident in, that uses a build system that you know, and not something that uses, from your perspective, and I'm not judging any programming language here, an exotic system. If you are a Haskell programming shop, then choose the Haskell library over the Java version. If you're a Java shop, then the Java version is the better solution, because you don't have Haskell expertise. It's not a statement that one language is better than the other. Check that it fits your support release strategy. A lot of the enterprise-ready Apache software, like Tomcat, they have an 8-year maintenance life cycle. So if you're in the business of offering yourself 5-6 years of maintenance to your customers, that's a good choice. A lot of the JavaScript libraries, they only support the latest release and maybe one release version earlier. So they more have a maintenance life cycle of a year or maybe even shorter. That might not be the right dependency for a product with a long maintenance life cycle. If you are yourself offering only half a year of maintenance life cycle, or you're a pure cloud-based product where you can change the versions whenever you like, then this is not an important criteria for you. There are indicators like, if the open source projects publish vulnerabilities, not necessarily in the CVE, it's not mandatory to publish vulnerabilities in the CVE, so it's completely fine if they do it on a dedicated website on their project web page. But if they communicate clearly the security vulnerabilities they fix them in time. If they have, for example, a communication channel where you can notify them about security issues in a secretive, in a private manner, so that you are not creating a 0-day when notifying them about security issues, that are all indicators of a good security culture. And the Linux Foundation actually has an initiative called the Core Infrastructure Initiative that looks at these kind of factors and hands out badges to the projects. That initiative is now 4 years old, and we are seeing more and more projects getting bronze, silver, or gold badges. They are not yet shown that prominently on websites, at least I haven't seen them. But that is, of course, another indicator that helps you in deciding. And then also smaller components might have a smaller attack surface. I've seen usages of Apache Common, which is already a pretty large Java library, and the people were only using one small function of 3 lines of code. Then one could question why using an external library and not only implement those 3 lines yourself, because also vulnerabilities that are in functionalities that you are not actively using might endanger your product and might require you to update a component and ship an update for your product, which means you need to issue a security message to your customers, and your customers need to upgrade their systems. Something that you would like to avoid, of course, as well. Then, that cannot be said often enough, document and monitor your dependencies. So be aware what open source components you are using and which versions of them and in which products. And it's not only a one-time issue. I'm writing down which dependencies I'm using, I'm fine with it. You need to monitor continuously, and there's one thing where open source components are significantly different to third-party libraries offered by commercial vendors. Whereas by a commercial library, you will have in the support contract that the supplier of the library is notifying you in case of security issues. So you have a push. For the open source libraries, you need to do a pull. You need to check whatever source they are using for publishing security vulnerabilities and fixes, and check them regularly yourself. That means you need to look into the CVE or whatever other website or technology they are using for that. For both parts, there are tools available that help you. So for building up a software inventory, you can, of course, use the build systems of your programming language of choice if you have them. So Packet for the .NET world, Maven for the Java world, or NPM, for example. They are able to produce a list of all dependencies and also the recursive dependencies, so the dependencies of the dependencies. There are tools like the OWASP dependency checker that then takes that information and tries to find CVEs in the CVE database and informs you you're using a version of a library that has a known CVE. You might want to upgrade. And there are package artifactories, so local copies, local clones of package repositories that you can use for controlling the access of outside world package repositories to your developers, and that also allow you to set up multiple streams or configurations so that you have a configuration with the versions that you consider stable and the ones that you kind of have in a staging setup that you still want to evaluate before they go into production, for example. So those are all good tools, but you need to plan the effort for working with them, and of course you need to learn how to use them. And similarly, there are tools for querying the CVE. So again, there's the OWASP dependency checker for Java. There's also Retired.js. NPM, in the meantime, has the NPM audit security tool integrated. So tools are available, but it's still a third at least manual effort, and only 2/3 or so can be automated, and automation is not available for all programming languages and all build systems. Then again, maintain those dependencies. It's for sure a good idea if you have longer development cycles that you check the versions of the components before you ship a new version to customers. My experience is that development teams request new open source libraries when they start development, then they develop for half a year, if you're in the traditional development life cycle, and then they ship to customers a brand new version of your product containing already old dependencies. So it might be a good idea to take the last quality gate or whatever it is called in your development organization before handing over the product to the final integration tests to check that all the dependencies are up to date. You need to plan effort for either upgrading your software to the latest open source components, or if necessary, to downport fixes to an old version of an open source component if you don't or want or cannot upgrade your software because the API changed, for example. this then also requires not only planning effort, but also giving responsibility to people that are actually responsible for looking after the open source components that you are using. There's, of course, commercial support available. There are quite a number of companies that offer commercial support contracts for open source libraries, and that's a viable option. Make the assessment yourself, depending on how much open source you use and what your risk appetite is and what the outcome of the risk assessment is. Outsourcing that work and kind of the risk to a support company might be the cheaper option for you. Not true in all cases, but it is an option. Lastly, harden your development environment. We've seen attacks against your actual development environment. In the real world, there were actually quite a few, because that seems to be easier. And whatever you install is installed under the permissions, the authority of your installation user. So if a developer is using the regular development account that he or she is also using for accessing internal systems like the HR system or whatsoever, actually an attack against the development system can be a serious attack against the intellectual property of your company. Not only sending out environment variables or values of an environment variables to a third-party server, but also your financial report or your sales pipeline. So keep that in mind. So check that you downloaded the right component that you actually want to use, not one with a similar name. It's more and more common, instead of using package managers, to have installation scripts which just clone arbitrary GitHub repositories. And as much as I like GitHub, the one thing I really, really hate is forking is so easy and you never know which is actually the master repository. You never know which is the repository which actually contains the latest bug fixes. And also keep in mind, if you're working with a repository, what you clone now can be something different that you clone in 5 minutes, or what you cloned 5 minutes ago. Using secure connections for downloads, that is also hopefully no issue. Now hopefully everybody switched to HTTPS, not only for package downloads. Ensure that signatures of packages are checked if you're using a package manager that supports signed packages. Use an own Artifactory package server. I said that already. I personally also consider containerizing your build environment for a good idea. I'm always a little bit frightened if I'm just cloning some repository, and if it's only a repository of one of my students, and execute the code of my machine. Not that I'm believing that my students intentionally are doing something bad, just because some stupid bug. Somebody wrote a shell script with an installation routine, deleting some repositories, forgot that some people have spaces in directory names, resulting in problems deleting something different, adding a space where no space should be. I guess some of you might have already done an RM star.something and had a space between the star and the extension, and suddenly a lot of files were lost. So there's not necessarily bad intention behind. But still there's a certain risk. So thinking about containers, virtual machines, dedicated setups for build environments is a good idea. Finally, just one slide. What I'm doing besides working with companies, helping them to avoid some of the mistakes and improving their software security, I'm also doing some academic research in that area. So more on the economical side, we are looking into finding indicators if it's for a company less effort to maintain open source packages centrally versus locally in development teams. There are also simple convincing example. If you have 50 development teams that use Tomcat in a specific version, then clearly it doesn't make sense that each of those 50 teams is maintaining Tomcat in that version themselves. there a central maintenance approach is obviously the cheaper one. And if you have a small library that only one development team uses, then most likely it's cheaper that that local development team takes over responsibility for that library, because they know what the library needs to do. They most likely know the development environment of that library, which the central team would need first to acquire new knowledge. Then we are looking into static and dynamic testing approaches to understand better which APIs are actually used from components, to estimate the effort of upgrading components, and also for developing automated fixes of components. And those automated fixes can either be in the component that is consumed, or we are also trying to come up with ideas in changing the code of your application so that the overall application is secure, even so a potentially insecure library is being consumed. So a simple way of that is, for example, if you know that a library has a SQL injection problem or a cross-site scripting injection problem, you might be able to do whitelisting on the application level instead of in the library itself. So those are kind of research work I'm doing in that area. And I'm closing my talk not with the standard thank you slide. Just wanted to reiterate on the last slide the key takeaways. If you are developing software, you are responsible for all your dependencies. For me, the key winning factors really minimize the attack surface of your application. That's not only good for minimizing the risk of third-party components, it's in general a good approach of minimizing the likelihood that a vulnerability has a severe impact on your application. If you're using open source libraries, in particular for open source libraries, because many people always believe they are free, I'm only downloading them and that's it. Plan efforts for maintaining them. Do some estimates in your development team. How much time do I need to assign to somebody that in case of a vulnerability needs to upgrade the library, needs to check that the new version actually satisfies our needs, does not harm the business functionality of our application. There are no unwanted side effects from an update. So you get a lot of software for free, and I'm a big fan of open source, but if you use it, it is something that you need to plan for. Monitor the vulnerabilities in your dependencies and act on them in a timely manner. Keep in mind your customers will monitor the CVE database as well, and they might spot that you are using a component that has CVE published, and they might contact you, and then you would like to have an answer immediately right away there, where you can either say, yes, we looked at that issue for this and that reason, that vulnerability doesn't affect our application and you are secure, or you might answer, yes, we are aware of that, a new update to our application will be available in the next N days, weeks, whatever the expected time frames in your business area are. Control your dependency sources. So check that you're really using dependencies from either trusted repositories, and that could be package manager repositories, that could be operating system repositories. So if your system is mostly running, let's say, on an Ubuntu version of Linux, then of course the Ubuntu package manager is a trustworthy way of including also development dependencies. And Linux distributions like Ubuntu or Red Hat have long-term support releases that get security fixes for all included libraries over multiple years. Again, check what the accept durations are for whatever Linux version you are using. And that applies again to all type of dependencies with slightly different priorities. So also think about your proprietary dependencies. And the final thing, always important for security guys to remember, building a hard-to-break system is much, much harder than finding problems in a system. So don't believe that the developers are stupid that are doing those stuff because they don't want to learn security. It's just tremendously hard to build secure systems. It's much easier to break a system. It's avoiding all vulnerabilities versus finding one. Thank you very much. I hope for interesting questions.